So here at WyoTech, we're working with a dyno, and this one specifically is a DynoJet two-wheel drive chassis dyno. And the main goal that we're trying to do with this is we're trying to measure torque. From there, the dyno actually uses a calculation and it gives us a horsepower reading. And if we make positive changes and we're making more power, we know we're going in the right direction. If it all of a sudden drops power, hey, we know we're in the right area, but we need to change it, maybe pull back, timing, something along those lines in order to increase the power. So the nice thing about a dyno is it's a stationary highway. There's a lot of people, they'll kind of run their car through the paces on the streets. Which trying to abide by local laws is kind of difficult to do. So we're gonna do it in a safer environment. And the cool thing is we can get in here and we can do some tuning on our laptop inside the vehicle. And that gives us the ability that we can make some changes and then see how the car performs with it. The seat of the pants dyno normally never lies, but the dynamometer actually gives you the hard data. And that's what you need. Depending on the readings that we get from this dyno, we can make a couple different changes. We can either increase boost pressure, or we may be able to give it a little bit more timing, but make sure that our fuel is happy with its stoichiometric ratio, or at least in the air-fuel ratio we were aiming for, so that we can try to make this as efficient as possible, which means it's gonna make as much power as possible. Realistically, if your turbocharger is too large and it doesn't spool, then you may say, hey, I need to drop my size down a little bit, and we may try to go with a slightly smaller turbo. But there's also a couple other things that we can change, which is something along the lines of the turbo housing. So you can actually get one that compresses the pressure in the turbocharger more to help it spool faster. We've got several dynos here at WyoTech currently. A couple of them including a two-wheel drive DynoJet chassis dyno. We have a four-wheel drive DynoJet chassis dyno. We have a two-wheel drive Superflow in-ground dyno. And then we also have a Superflow engine dynamometer as well. So we'll do a nice little walk around of our DynoJet two-wheel drive chassis dyno. And over here you can actually see the brain box on the backside. That's actually operating off of a CAN bus network, and that is controlling what we call a eddy brake dyno. And so our eddy brake is actually housed in here. That is what is going to apply the load on the vehicle. It is actually transferred through a shaft and a U-joint here, and it connects directly to the roller. Now, the nice thing is this roller's got a pretty good knurling effect, so it holds onto the tires pretty well, so we have pretty good traction while we're doing a pull. When we come around to the front end of the vehicle, we've got a cooling fan here, and the nice thing is with this cooling fan is it allows air movement through the front of the vehicle just as if you were driving on the highway. The one downfall is we have an air-to-air intercooler on the front. If we are not getting air across there, we could lead into potential catastrophic issues where we are not getting enough airflow cooling the charged air or the pressurized air going into the intake. And it's going to end up leading into issues where it's either going to try to pull timing, or we may run into the issue that we hit detonation. So for the safety of it, the fan is actually there not only to cool the engine, but to cool the charged air that is going inside of it. So over here we have our dyno control. This is pretty much just set up through a ThinkPad, and all it's doing is running the DynoJet software. In here we can actually see a multitude of things. You've got engine RPM, you've got speed. If you connect the box up to it, you can actually read live data like air-fuel ratio. It actually has a sensor, so it's got barometric pressure, can test for humidity, everything like that. So it makes these tests as accurate as possible. Some of the other things is we actually will go in here and we'll change some run configurations. As we're going into here, we're going to be changing a couple different values. So like we're doing a 4th gear pull so that this thing's getting loaded as close to 1-to-1 as possible, so that we're testing the engine as efficiently as possible. So we're going to start roughly at 40 miles an hour, and the test is going to end at about 115 miles per hour, which puts us right around like 82 to 8,300 RPM. So it's about the top limit. The car, we can push the RPM more, but we're trying to push the power at a safe RPM level. So just after we showed you guys kind of a quick walk around to the dyno and how everything operates and whatnot, now we're going to take you inside the car and kind of show you what we're looking at a little bit. We've got some of our basic gauges up here that you can see on the dash. We've got fuel pressure over here so we can monitor that, because if a turbocharged car ever goes lean, you're going to run into some catastrophic failure. On the right side over here, we have our air-fuel ratio, which is also watching to make sure that we're within our tolerances for lean and rich as we are making our pull. Over here, I've actually got the Honda computer software. So as we are running through it, we can data log it, which gives us the capability to take a snapshot of a specific time frame, RPM, what all the sensors are doing within that time, and we can actually go back and make modifications as needed. The other thing is I can also make sure RPM is reading correctly to the dyno and that all of our information is transferring over as it should. Whenever you're using a two-wheel drive chassis dyno and you are only driving two of the wheels, one thing that is almost always going to happen is if you notice on the dash, the ABS light is on. That's because right now the vehicle, or the computer as it sees it, is the front wheels are spinning and the back wheels are stationary, which it thinks it's in a wheel lockup for the most part, or in a catastrophic stopping event or something along those lines, and it's registering that as an error, so that's pretty common. Just make sure that you have a scan tool or something along those lines. Otherwise, it just takes a couple key cycles and that'll end up going away. We've managed to hit 571 horse so far. So we've got a couple different things. We can change the load on the dyno, how much boost that it's peaking in. We actually did increase some boost numbers just a little bit, so it should make some more power. But the main thing is if we can get the dyno to apply the appropriate load, we should be making boost sooner, which then should actually give us a higher peak. The other thing is we're also increasing the rev limit from 8,500 to 8,800 RPM now. At the end of the day, the nice thing with the dyno is that it proves that our engine theory, our piston selection, our ring gaps, everything is kind of working together. The other thing is we can also make sure that the turbocharger is not a restriction, nor is it too large and we can't actually effectively use it. So overall, it just ties in all of our theories and all of the work that we have done so far to make sure that it works correctly. All right, guys, so when you're trying to boost your car, make sure you get that data. We'll see you in the next video.